Okay, this is Chapter 3. Chapter 3 is about the relationship between chemical reaction equations and relating amounts of reactants to products to reactants, reactants to other reactants, or products to products. Basically, relating amounts inside of a chemical reaction. Before we start that, we need to first define the term molecular weight, which is the sum of the atomic weights in a molecule, and formula weight, which is the sum of atomic weights in a formula unit. A formula unit is basically an ionic compound. So these two definitions are essentially the same thing. It's just this is for a molecular compound and this is for an ionic compound. It's the only difference there. So we're going to start out by doing some problems. Okay, it says find the formula weights of the following substances, 3 significant figures. Okay, so the process that you do is that you take them. So for hydrogen, I have 2 of them because of the 2 right there, times, and then I come down here to the periodic table, and 3 significant figures would be 1.01. In general, I say I always want 2 decimal places with that, so that's going to be 2.02. Okay, sulfur, there's only 1 of those, and depending on the periodic table that you use, this one happens to be 32.06. Sometimes it's 07. That's 32.06. And then oxygen, for this one there are 4 of them, so 4 times 16 is 48. And then I simply add these together. So 2.02 plus 32.06 plus 48.00 is going to be, I don't have a calculator in front of me, 0.08. That's 10, 12, and 82.02. Okay, and we haven't gotten to this yet, but the units that we're going to be using is grams per mole. Okay, all right, for the next one is PCl5. Okay, so I'm going to change color so you can see which one's which. Okay, again, same process. Phosphorus, there's 1 of them, and each phosphorus is 30.97. Chlorine, I have 5 of them, and it's 35.45. And that one I don't want to do in my head. So 5 times 35.45 gives me 177.28. Okay, and then I add these together. And I get 208.22. And this did say just 3 significant figures, but like I said, I always do it to 2 decimal places. But this would be 208 grams per mole. This one, I didn't do it to 3 significant figures, would have been 82.1 grams per mole. Okay, and the last one is ammonium chloride, because this is an ionic compound. So I do the same process for nitrogen. I have 1 of them, times the 14.01, which came from rounding this to 2 decimal places, gives me 14.01. Hydrogen, there are 4 of them, times the 1.01. And chlorine, there's 1 of them, times the 35.45. And so when I add these together, that's 0, 5, so 0.5. 8 and 5 is 13. So 2 and 3 is 53. So it is 53 point, oops, that was different. 0.5 grams per mole. And that's all for this particular